So how do we use code to compute probabilities? The basic idea is you have an experiment that you're interested in. Remember, an experiment is just the thing whose result is random. And we just run that experiment over and over and over again on the computer and count how many times we see every outcome. So here's an example. What's the probability of getting 60 or more heads if I flip 100 coins? Okay, so I'm going to flip 100 coins. I'm going to get a certain number of heads. What's the probability that the number is 60 or greater? Now, it turns out I can calculate this directly with math, okay, by hand. But it's also easier to do this with code sometimes. So how would we do it with code? Well, I'm going to approximate this answer with simulation. I'm going to figure out how to do one experiment. And an experiment here is flipping 100 coins. That's one experiment. And then I'm going to do that a bunch of times. I'm going to flip 100 coins, flip 100 coins, do it again, again, and again. And then after I do this maybe 1,000, 10,000, 100,000 times, I find the proportion of times, or the fraction of times, where the number of heads was greater than or equal to 60. Now, keep in mind, this is an approximation. This is an approximation. The answer is not going to be exact. It's not going to give me the exact number, but the more times I run this experiment, the closer I'm going to get. Okay? You can imagine doing this 10 times, running this experiment 10 times. You're not going to get exactly the right answer. It could be a number with a lot of decimal places, and if you run it 10 times, your answer is only going to be accurate to one decimal place. Or not even that. It'll be close. It'll be within 0.1 maybe, but there's a chance that it'll be further away actually, just due to randomness. But as you run your experiment more and more, you'll get closer, is the intuition. So how do we simulate something random with code? Well, one of the ways that we do this is with a function from NumPy called NumPy random choice. This function takes in several options, several possible outcomes, and it returns one of them at random, uniformly. It picks from them uniformly. So for example, I want to flip a coin. The two outcomes are heads and tails. So I say, okay, NumPy random choice. I give it a list here. You can give it an array as well of possible outcomes, and it'll select one. Heads in this case. If I run this again, get heads, tails finally, then heads, getting lots of heads there, which, I mean, randomness sometimes doesn't look random. Sometimes you see a lot of heads, but it is a fair coin here. Okay, now you don't have to have only two outcomes. You could also add a third outcome here, and you'll see that sometimes. Okay, you could have as many outcomes as you'd like. Okay, so moving on, if I want to make multiple random choices, there's an optional argument to random choice. So for example, if I want to flip a coin 10 times, so in other words, I want to select something from this list, and I want to do that 10 times repeatedly, then I give a second argument here, 10. So that says, give me 10 selections from this list. Okay, so it said, well, my first selection was tails, then I selected heads, then tails, and so forth. So this is one way that we can simulate flipping a coin 10 times. So we're partway through our experiment of flipping a coin 100 times. Now, we have to stop here to talk about two different ways that you can select something, with and without replacement. You notice here, I am selecting heads, or the first time I selected something from this list, tails, I can select it again later on, tails. That means I'm sampling with replacement is the terminology here. You can think of it like, okay, I have a list of two things. I selected one. After I select it, I put it back in the list, and I can select it later on. That's what it means to select with replacement. The other way to do this is without replacement, where once I make a selection, I can no longer select it again. So we can tell NumPy which we'd like to do with yet another argument, a keyword argument, replace. Now, if we omit this keyword argument, the default is to do selection with replacement. But if we specify that replacement should be false by saying replace equals false, then it'll select without replacement. So let's try it out here. I've got a list of 4 people. I'm going to randomly choose one. I'm going to randomly choose 3 of them in order. So I choose Yvonne, then Zelda, and Yvonne. And notice here I've selected Yvonne twice because I'm sampling with replacement. But if I say replace is false, try to say replace is false, and then I run this, you'll notice that I don't have any duplicates. And if I keep running this, you'll notice I never have any duplicates, because once I select Zelda, I don't put Zelda back into the list. So keep in mind that I can only do this up to the number of people that are in my list. If I have 4 people, I can run random choice and say select 4 of them, okay, and it'll give me a permutation of those 4. But if I say give me 5, it'll yell at me, because you can't select 5 people with replacement or without replacement from a list of 4.